In this example, we're going to find two different algebraic rules, one involving sine and one involving cosine, for the function y equals g of t graphed here in figure 6. First, let's get a template for the functions that we're going to find. And when it comes time to find a sine formula, we're going to want it to look like this. G of t equals a sine omega t minus h plus k. And when it comes time to find a cosine formula, we're going to want it to look like this. G of t equals a cosine omega t minus h plus k. Now it turns out that the sine function and the cosine function both have the same period, which is 2 pi, the same amplitude, which is 1, and the same midline, which is y equals 0. And since they both share these three features, the values for a, omega, and k will be the same in the sine formula and the cosine formula. So essentially we just have to find those once, and we can use them for both the sine function and the cosine function. The only difference between these two, the values in these two formulas, is going to be the value h, because h concerns the horizontal shift, and we'll need to shift our function a different amount, whether we're treating it like a sine wave or a cosine wave. So we'll get to that at the end when we're actually piecing together our final formulas. But let's start by finding the values of a, omega, and k. To do that, we'll need to determine the midline, the amplitude, and the period. So let's get started on doing that. The midline is the midpoint between the maximum y value and the minimum y value. So we need to find the middle of the values 1 and we'll want to find the midline, the amplitude, and the period. Let's start with the midline. The midline is in the middle of the function's maximum y value, which is 1, and minimum y value, which is -7. So we need to recognize that it looks like -3 is right in the middle of 1 and -7. So this line, this line here, y equals -3, is the midline. So our midline is y equals -3, and that turns out to dictate what the value of k is. K represents the midline in the algebraic rules, and so piecing these two together, we realize we're going to have to use the k value -3. And we write our formulas at the end. The amplitude is the amount of distance between the midline and the maximum y value, or another way to phrase it is the distance between the midline and the minimum y value. So it's going to be the distance here between 1 and -3, or it could be calculated here as the distance between -3 and -7. In both cases, you'll notice that the distance is 4 units. And so we know the amplitude is 4 units. And connecting this information with the algebraic rules, we've learned that the value a represents the amplitude, and so we know that we're going to need to use an a value of 4 when we construct our final answers. Now, the period of this function can be calculated in a lot of ways, but probably the easiest in this case, because there's nice solid dots, is determining the distance between where the function reaches this maximum value and then where it reaches the maximum again, where it starts over and starts repeating itself. That will be one full period. It looks like this the ending point here is 6.5 units, and the beginning point is 1/2 or 0.05 units. And if we do the subtraction, we see that the period is 6 units. So we can list the period as being 6 units. Now, the period doesn't actually appear as a number in the algebraic rule for the function, but the period is intimately connected with the value that we use for omega, because omega causes a horizontal stretch, which will give us the desired period. Since we're working with the sine function or the cosine function whose periods are 2 pi, omega is going to need to stretch or compress the length 2 pi into the length 6. And so what we need to do is take our period of 6 units and have it produced by taking the intrinsic period of sine and cosine, which is 2 pi, and then stretched horizontally by the reciprocal of the number that we'll use for omega. So we just need to solve this expression for omega. If I multiply both sides by omega, I can pull the omega over to the left and simultaneously divide both sides by 6. I'll end up getting the 6 on the bottom on the right and reducing this fraction. We see that we're going to need to use an omega value of pi over 3 in order to obtain the correct period. So now we can get started on drawing, expressing our sort of final answers here. When we try to find our formula using sine, what this will mean, what the work that we've done so far will mean to us is that our formula will need to have the form g of t equals a, which is 4, sine omega, which is pi over 3, t minus, and we haven't figured out what h has to be yet, plus k. K is negative 3, so we can write that as minus 3. Similarly, we could take our cosine rule and come down here and recognize it's going to have the form g of t equals 4 cosine pi over 3 t minus, we don't know yet, minus 3. Barely fits on the window. Okay, now what we'll need to do is determine what h needs to be. When we're trying to find a formula that involves sine, we'll want to think in terms of sine waves, which start at the midline and come up out of the midline. So we'll want to find a place in this function, in our graph of g of t, where the function is crossing through the midline and coming up out of the midline. And one example of a spot for that would be here, looking at this wave. Notice if we imagine the wave starting at -1, it seems to have the shape of a sine wave. So what we could do is let h be -1, and in that case we would have the function h would be -1, giving us our algebraic rule. If we look at, from the perspective of cosine, cosine is at its maximum where it we're used to it starting. And so we look for a place where the function's at its maximum. We can go up here at the peak here and consider this as a cosine wave. This is the kind of shape that most of us would think of as being associated with cosine. And in this case, it looks like the horizontal shift here is at 1/2 unit. And so what we could do is use 1/2 as our value for h and obtain an algebraic rule for this function. So here are two formulas for the function g of t, one involving sine and one involving cosine.